Hi, Auntie. Has the time changed for the spring or is it still 6:15?
We start, Naisha, we have been doing it 6:15, right?
Yeah,
No. What is this question? No. I didn't get your question.
we're still starting at 6:15, right?
Yeah. Yeah. You're thinking we're a few minutes later. Hey guys, for some reason my laptop shut down completely, so I'm joining. Is it okay? Guys,
Yeah.
for some reason my laptop shut down completely. I'm rejoining, okay?
Oh, okay. Okay.
Give me a minute. Hey Naisha, have they completed polar graphs, ma?
Uh, yeah, I think, well, no, hold on. Let me see. We're starting a new unit. Let me see what we're doing.
Right now, I think we finished polar graphs because right now we're doing the cotangent, secant, and I forgot the other one, but yeah.
Yeah, inverse. So are they covering inverse trig functions, huh?
Yeah.
Mm-hmm.
Cherry, polar graphs, how much they have done?
Polar graphs, we did the transformations from rectangular to polar and back. I think we finished our polar unit. We did the graphing polar and yeah.
No, I really want to understand, ma. Would you mind sending me a copy of what you're doing?
Yeah, I'll send it to you, Auntie.
Because polar graphs, have you completed Lemnis skates, Archimedes spiral and stuff?
No, we haven't done that.
See, then how do you say it's complete? That's why I wanted to know what have you done?
Because
Priya?
they said that we weren't gonna go into in depth that much because they said it's not covered that much in the AP test. But I'll send you how much we've done so far.
No. Polar graph is getting covered, right, as a part of AP pre-calc as well. I don't know. See, that's why I want to know your what is that they are doing for you. We'll go ahead, Nidhi and yeah, Nidhi, the same thing for you, Nidhi.
But Biba, we did limicons and then we did like the graphing, like the spirals. We did that in class.
Oh yeah, that will come.
Yeah.
Yeah, we did that.
Oh,
But
good.
after that, we did like the inverse trig functions and things like that.
Okay. So you have done Archimedes rate of change of polar functions. Have you done?
I
In
don't
the
think so.
what?
Our teacher, she just gave us the notes and then she was like, here, learn it. Like she didn't teach us anything. She just gave us the notes and she
Yeah.
was like, try to figure it out.
Because they said polar wasn't like weighted really heavily on the AP test. So our test on polar was like a project as well. So it wasn't like that in depth.
Hmm.
I see. Okay. For you, Nidhi, what is going on, Nidhi?
We finished inverse trig and trig equations, and now we're on law of sines and cosines and some and vectors. And then in a couple weeks we'll be doing polar graphs.
Oh, I see. Okay, vectors, I'll go a little later. That is an easy topic. Polar graphs and rates of change in polar graph will take a little bit time with me. Okay, let's go ahead. 1 second, guys. 1 second. I really want to. I don't know what the others are doing. Let's see. Give me a minute.
Oh wait, Auntie, wait, Viba, we did the rates of change. I'm looking at our notes packet and I just realized our last class, all we covered was rates of change in polar functions.
Dude, wait, which is Rachel? Wait, last class isn't, wait, was last class A day or B day?
Last class was a B day, and we did the entire rates of change of polar graph. We'd finished the notes for that.
Let me check.
So we did that.
Wait, this
Mhm.
class?
Yeah.
So, have you done your test on that as well?
We
Mm,
haven't done the test on that, but I think it's coming up because 3.15, I think we do have a test. So we did like the entire notes packet for rates of change of polar functions.
Correct.
Yeah.
3.15. I see. 3.14 is your benchmark. 3.14 A, B are the graphs of polar functions
yeah.
and
Yeah.
rate of change of polar graphs. Correct.
Yeah, 3.14 was the one where she just tossed out the notes and she was like, you can learn it yourself. But then
Yeah.
3.15 we went over like with the teacher and everything.
Yeah, I just saw it.
Oh my gosh. 3.14 is hard to go over.
I
Oh,
know, and she like we were trying to learn it, so we were watching videos on YouTube, me and my friend, because she didn't teach us it.
oh, for 3.14. You okay.
And we're not gonna have a test over 3.15 either. I just checked the calendar.
I see. Why?
They said that polar wasn't important, so
Yeah, I don't know what's
yeah.
going on with our.
Okay, okay. So the only units that are left are parametric functions, conic sections, vectors. Those are the only units that are left, but we'll do that later. That's the fourth unit that's left. 1, 2, 3 gets completed today is what I'm thinking. Let us see. Okay. Last week we did. So were you able to understand for A sine B theta or A sine cos theta? This at least this graph, were you able to understand, or did you want me to go over this once more? You have to clearly tell me, guys.
Can you go over once more, Auntie?
Yeah, sure. Okay, let's see. Where is my preview? Everything restarted. I'm having a hard time here. Hold on. Give me 1 minute, guys. Everything I had it open, all gone. When Nitin, for you, how is it going? What are you doing?
We have a test on Tuesday about polar functions, like polar function graphs.
Oh, good. Okay, good to know. Okay, then we are good. Okay. Next week, I intend to start with the other one. Let's see. Okay, let's go over once more quick. 4 cos theta, 4 sin theta. We'll take a blank graph. We'll try to graph that and see. Okay, let's go ahead with 4 cos theta. Then we'll go ahead with 4 sin theta. See, this one is what we did last week in class. Naisha, you were not there for the first class, right, Naisha?
No, Auntie, I was there last class.
Oh, okay. When we discussed the graphs of 4 cos theta and sin theta?
Yeah.
Okay. Oh, I wanted a graph as well, right? Okay. Do you know how this graph? Let me add one more graph for this. So you know how to graph this? What do you do? You tell me, Naisha. What do you do?
To graph the
I'll
like
help you.
on
Go
a
ahead. Do it together.
on a rectangular or on like the polar.
On the polar, ma. Polar. Oh, I didn't share my screen. Yeah, I've shared my screen, right, on the polar graph.
So isn't the A value the radius? So
Mm-hmm.
you
A value
do
the radius. Good.
4
So
down.
this we take as the radius. So what do we
Mm-hmm.
do? Do we do here,
No, it would be,
here,
yeah,
or here?
it would be on the like the starting in the standard position, right? On the uh right side of the
Yep. Yep.
yeah,
So
so it'd be 1, 2, 3, 4. Yeah.
Good job. So here basically just like a linear graph, right? We would go ahead and find out. We'll put a table to start with. That's the best way. Okay. Once you get used to, then it becomes easy. Okay. For easy sake, I'm not going to the calculator. I'm not going to type. Literally, I'll have a table R and theta values. Okay. So R value is 4 cos theta. You're going to put it in a calculator. 4 cos theta. Now for theta equal to 0, I'll substitute this is 4 cos 0. Then I'll substitute 4 cos pi by 6. 4 cos pi by 4. 4 cos pi by 3. 4 cos pi by 2. Like this I'll substitute, get the values in the calculator. Okay. Now for 0, it is a 4. Okay, that's the pole, meaning that's in the x-axis. This is the pole, right? So that's 4, and then pi by 6, it's 3.4 something. I'll plot this. Pi by 4, 3.4, pi by 4 is 2.8. 2.8 in the sense it's like this. And then pi by 3 is a 2. Pi by 3 is a 2. Pi by 2, pi by 2 Pi by 2 is a 0. Really? Am I doing it correct? I'm not doing it right. 2, right? 2 means 1, 2. 2 is a 0, and then you've done it correct. 2 pi by 3 is a minus 2. 2 pi by 3, where is 2 pi by 3? 2 pi by 3 is a minus 2. Do you guys see it, guys? It's basically symmetrical for that matter, okay? So here we go. Here, where is it? Just outside this. So when I connect all of this, do you see this is what I get? So from here, you'll have to remember that this is the radius. You see, 4 cos theta. Now let's go ahead and do, this is what we discussed last week, right? Any questions on this? Okay, how about 4 sin theta? Same thing you'll do, right? Same thing you'll do in the sense 4 sin theta, you should have a table. Let me see if I have a table ready. I'll give it to you. I have, but it's not in a format I can. Okay. So for sine theta, let me put it into a graph. 0, 0. So that's going to be based on the graph. I'm not going to draw the graph in here. If you want to, I can, but let's see. I have some pictures. Let's see. So this table I'll follow just like the last one. Okay, just like the last one, we have 0, 0. Let me plot it in blue here. 0, 0. Then pi by 2, 4. See, pi by 2 is a 4. You see, this and this plotted, pi by 6 is a 2. Pi by 6 is a 2. So do you see what is happening here? Similarly, this will also be a 2. So this will be something like this. Any questions, guys? Okay, can I call this as opens up? How about this one, the previous one? Can I call the sine graph? This is a cos graph, right? Cos graph opens right. Can I say that? Now, let me ask you, R will be equal to minus 4 cos theta. What happens here? Let me put it into a different color. So what would happen to that because of this minus 4? What would happen?
Would it be reflected?
Yeah, it will open on the left. Makes sense? Same thing though. It will be 4. Okay. Here, what would happen if it is a minus? Minus 4 sine theta. I'll put it in a different color. R will be equal to minus 4 sine theta will be?
On the bottom?
Yeah, but it will be 4. The radius will be 4. Any questions? Okay, so this basic graph we know now. The second graph also we discussed in yesterday's class. See, I don't want to put a table and it takes a lot of time for me if I put the table, go to the calculator, check. Nitin, are you following till here? Nidhi,
Yeah.
you're okay. Nidhi, you're okay, right?
Yeah, I'm okay.
Okay. Now, how did we determine the cycle? I also wanted to share a GeoGebra link with you guys. Let me see. Did we do? Yeah, I think we did the GeoGebra link. GeoGebra or Desmos we did, right? If I remember right, what did we do? I don't remember. Desmos polar graphing, huh? Last week we saw this one, right? What is the cycle of these graphs? We went to demo. Remember, I showed you this. Show you. Let me show you guys. Give me a minute. Share. I want to share with you the Google Chrome. You remember this one? We did 4 sine theta. What was the cycle? We used the slider, remember? Please meddle with all this, then only you'll remember graphing nicely. So when we start from 0, do you see what happens? It goes, 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 it goes. One cycle. Do you see the value? See the values of theta as well. We are only working with r, right? 4 sine theta. Do you see? One cycle gets completed at what point? You see the blue dotted line. The blue dotted line is at the pi. So one full circle is completed at pi. What happens after pi? The values just repeat. The values just repeat till it goes to, oh my gosh, till it goes to 2 pi. So when you look at the table, I want you to look at the table now to see, hey, what happens? So when you look at the table, oh, I can't paste it here. That's bad. 1 second, guys. Okay, I don't know. Yeah, let me share it like, I don't think I can paste it, right? Give me a minute, let's see. No, I can't paste it here. Okay. Maybe I should share my desktop. Let me see. Okay, so guys, see here. Do you see the table here? You all see the table, right? For this is basically for sine theta. This is basically for sine theta 0, 0. 4. This is 4 sine theta. When you look at it, right? 4 sine theta 0 to pi. 0 to pi. It gets completed here. Again, it comes to 0. See what happens. Pi, it starts at 0 and then goes to 1 second, guys. I want to show the table for you. Hold on. I want to show you in the graph. See, when you look at it, right, let's see what happens here. You're seeing the polar graph now in Desmos calculator. So I use the slider. Play with this, then only you'll clearly understand what happens between 0 to 2 pi. 0 goes. See, the yellow dotted line shows you the theta values for pi by 6, pi by 4. You see here? And then pi by 3, pi by 2. Pi by 2, it becomes its maximum, right? So that is the maximum 4. And then it reduces. See, now I also want you to understand something here. If suppose I convert it to a rectangular graph, right? What happens here? This is 4 sine theta, right? So what happens here? Can I put this as 4? What? So see, from 0, it has basically in a sine theta graph, right? What happens? It goes till in a rectangular graph, guys, what happens? So here, from here, you go to pi by 2. So in a polar graph, it goes like this, right? In a rectangular graph, what happens? Basically, it starts at a 0. Then what happens in a rectangular graph? Let's say this is pi by 2, pi. What is the period of sine curve or a cos curve?
2 pi.
2 pi. So till pi, what happens?
At pi, wouldn't it be like rising and it cross?
Yeah, it goes down and comes back, right? So the same thing happens here. So 0 to pi. So let's do this 0 to pi, 0 to pi by 2. Let's consider 0 to pi by 2. Let's compare 0 to pi by 2. It's very important because as we move up, I'm going to compare a lot. 0 to pi by 2 will be this. So what happens? 0 to pi by 2, right? So till here, from here, you see? And then when you go to the next one, right? So you should be able to compare from pi by 2 to pi, right? That's going to go like this, pi by 2 to pi. So it touches, see, it touches the x-axis. That time it touches the pole. Any questions here? Then it goes through negative, then it reaches the pole again. Again, one more full circle. So this is how you compare the polar graph and the rectangular graph. Slowly we will compare, we'll split up the graph into 4 pieces and compare what happens when it is going up, when it is going away from the pole, when it is decreasing, when it is going towards the pole. So all that we'll make a comparison between polar and rectangular. For now, we have just drawn the graphs of 4 cos theta, 4 sin theta, minus 4 sin theta, minus 4 cos theta formats. Okay. So now let me go ahead. Go to notes. Give me a minute. Okay. So blank page is better. Okay, having said that, I really want you to understand the period was 0 to pi. For the polar circle to complete, right? We did from 0 to pi on both cos and sine. Now, this also we did. We also tried to draw graphs for last week, I'm saying. What did we do? 4 cos, I don't want to say 2 theta. I want an even number. How about 4 cos 3 theta? I don't want to say 4 cos theta. It becomes odd. See, do you see now? First we understood what is sine theta graph, cos theta graph. Sine theta graph, this is 1 sine theta. So the radius was 1. So here cos theta graph, this radius was 1 again, but then this is towards the right, this is towards up, minus cos theta would be towards the left. Again, this would be minus 1. And then the last one is minus sine theta. That would be, I'm sorry. Minus sine theta would be opening down. Right? This is minus 1. So all these have a cycle of 0 to pi. Any questions here? Now we are going to go into this 4 cos 3 theta. Cos and what is this? Odd. So in this scenario, this is a little different. 4 cos 3 theta. To draw the graph and show you. First, let me show the graph. Last week as well, I showed the graph and then we went ahead with how we did it. Let me go to, am I sharing the Desmos? Yep, desktop. Let me see. Chrome, where is Chrome? Chrome. Good. Now I'm going to change it to 4 cos 3 theta. So let's see what happens. When I go from here, see, if I put a table with 4 cos 3 theta, it's going to take time. That's why nobody discusses that. R theta, right? Now, theta can be this pi by 3, pi by 6. I'll go ahead with pi by 6, pi by 4, pi by 3, pi by 2, 2 pi by 3, 5 pi by 6, pi. Let's just do that first. And then R will be equal to 4 sine pi by 4 sine 3 pi by 6, 4 sine 3 pi by 4, 4 sine. So if you're going to do this, it's going to take a lot of time. But based on that, I'm not going to find out the values in here. So let's move the slider and see how it works. See, so when you come to pi by 6, that is pi by 6, right? So when you think about it, it's 4 sine pi by 2, right? 4 sine pi by 2 is, sine pi by 2 is 1, sine, 1 second. Okay, what should be 4? So this would be 4 sine pi by 2. So this has to be what? 3 theta, right? 3 theta. 4 sine pi by 6 to 4 sine pi by 2. So what do you get the value of this pi by 6? For pi by, can one of you please do at least 3 of this and tell me in a calculator? Do this one and tell me in a calculator what do you get? I want you to do this in a calculator and tell me, guys.
Wait, Auntie, do you want it in radians mode, right?
Yeah. In radians mode, you just put a table. I'm not going to do all the values. Please, I want you to relate. See, it is touching. See, for pi by 6, that is correct. Whatever we are getting is correct. So this one, pi by 6, when you put pi by 6, this is pi by 2, right? Pi by 2 is 1. So this becomes a 4. Now, this I don't know. Okay, you'll have to do it in a calculator and see. This one clearly is 0. So do you see now, pi by 6 is its maximum 4. See 4. Then I'm saying pi by 3 is at a 0. Pi by 3, it turns to 0. Meaning, when my blue color dashed line comes here, it returns to 0. So, when I increase the slider, when it comes to that blue color line I have indicated, it has to come to 0. Supraj, are you getting it? See, the blue color line matches with my blue color line. It came to 0. Guys, do you see it?
Yeah.
You understand how this works? Guys, do you understand how this works?
Yeah.
Okay. So 4 sine 3 theta, right? This one. One thing, what you can, raw way of remembering this, right? Cos always starts with this axis. Cos always starts with this axis. Whereas sine never coincides. In no petals or no graph will not cover this axis at all. So this is 4 sine theta, right? Let's go ahead and increase the slider and see. So basically, see, this is odd, right? See, now where are we? See, this is pi. When the dotted blue line coincides with pi, it ends. So the cycle is basically 0 to pi only. See, 0 to pi only. 0 to pi, this 3 petals come up. So for 4 sine 3 theta, it's going to be only 3 petals. And then now I'll increase it and see. If I increase the slider, the same thing is gone over again. See? So for, let me erase this. Cos odd, meaning 4 cos odd means this one. When you have this as an odd number, right? In that case, you will have 3 petals. Okay, any other questions here? Any other questions here? You always start at 90 by 3, meaning 90 by b. Let's consider this as a cos b theta. Okay, b is odd. A can be any value. So that will be your highest value in the graph, meaning this highest value. This is the highest value in the graph, right? So that will be 4. Now let's consider 4 cos 2 theta. What do you think will happen? That is also a cos b theta, but then now it's different. Do you see? B is even cos. What will happen, you think? That's a little different. The graph is going to be a little different. It's tricky. Let me erase this graph. I'll go back and overview in a blank, re-emphasize or go over it again on a blank page, okay? So now let me go back. I said we have to experiment with 4 cos 2 theta, right? Let me go ahead and change that. 4 cos 2 theta. See what happens. I want to slowly see. See? 4 cos 2 theta means 90 by 2, 45. 45, it reaches its maximum. Where is 45? 45 is pi by 6, right? See? Does it? 45 is pi by... What is 45? 45 is pi by... Yeah. So see, Here is where it reaches its maximum, because I said 90 by 2. So 45 angle. This is the angle 45 where it reaches its maximum, right? And then what happens at 9? See. Okay. See, it goes here, here. I'm going to try to complete. See, now. See what happens. What happened in pi? When I came to pi, what happened? Did it complete? No, it didn't complete. The full graph was not complete at all. Do you see? I was on pi, right? Let me go back to pi. See, the full graph didn't complete at all. So I had to go through again another pi. So when I came to 2 pi, the graph got done. After this, it will repeat. So basically, what can I say about this graph? This has to be B times 2B petals are there. 2B petals are there. Starting point is always 90 by 2 is my starting point, meaning that's where it reaches its maximum first. So 90 by 2. So here it is 2B is 2B 90 by here B is 2, right? 90 by 2, 45 degree. That's my starting point where maximum is reached. So 2 B petals here. Here there were only B petals. Any questions on this? One thing is, when it is even, the period is 0 to 2 pi. When it is odd, the period is 0 to pi. Any questions here? Nidhi, are you following, ma'am?
Yeah, I am.
Okay. And what next? Let's see. So I told you a cos n theta, a cos n theta. One is odd, one is even. That we discussed. Sine. Sine is a little different. I want you to understand that as well. You're seeing the polar graph, right, guys? So I'm going to change it to sine theta. See, sine theta does not, when I have this as cos theta, automatically it will fall on the see, this is the best way to understand. Cos will cover this. Here is where will be your first maximum. Okay, sine will never touch this. So basically you have to do 90 by, suppose let's say we have 5 cos 3 theta. In this case, I will take this as n theta, meaning I can write it as a cos n theta. Now, n is odd, n is even. There are two things, right? When n is even, this will be 2n petals. When n is odd, will be n petals. The same thing applies for a sine n theta. N can be odd, n can be even. Here it is 2n petals, here it is n petals. Okay. For sine, how do you start? 90 by, you will have to do 90 by n to get the starting point where it reaches its maximum. The maximum is always this one. So here, this is 4, right? 4 is the maximum. This is always the maximum. A is always the maximum value. Now let's go back. So if it is double petal, meaning 2n petals, right? 2 times n petals, right? That time the cycle does not get over within pi. It has to go one full circle. So it is 0 to 2 pi. Okay. Now I want you to tell me R 2 cos 7 theta. Let's do 3 problems on this. I don't want to. Okay, let me go to the polar graph itself. It's fine. What did I give you? Let me ask you 2 cos 7 theta. Let's take up 2 cos 7 theta. 2 cos 7 theta. I want you guys with the whatever knowledge we gain right now, right? I would like you to tell me whether the circle opens up, down, right, left. Circle opens up, down, right, left. I want you to tell me 4 things. Okay. I want you to tell me. Way to write. 4 things. Circle opens up, down, left, right. Number of petals. Then I want you to tell me maximum distance from pole and cycle. Maximum distance from pole and cycle. What is it? Okay, you help me, guys. You're going to tell me. Circle opens where? 2 cos 7 theta. Right, left, up, down. Which one is it? Hey, can you try?
Doesn't it open to the right?
To the right. Cos means it opens to the right. When there is a minus, it becomes this way. You got it? Now, 7 means it's odd. So how many petals?
14.
Aha.
Wouldn't it
Isn't it
Even
7?
only doubles.
overlapping?
Even only doubles, so 7 petals.
But wouldn't it be 14, but like 7 are overlapping each other?
True, but we only see one cycle, right?
Oh yeah, wait. I forgot you call it only 7. Wait,
So
yeah.
0 to pi. Because it is odd, it's 0 to pi. Maximum distance from pole would be 2. Am I making sense, guys, or you are not clear? You have to tell me, guys.
Yeah, makes sense.
Make sense?
Mhm.
Okay. How about this? What happened? What did I do? Oh my gosh. The equal to sign is gone. See here. I really want you to want to show you that. See? Did we do it correctly? Let me move the slider and see. Try meddle with it when you have time, please. So now you see now? Oh, I don't want to repeat, please. I don't want to repeat. Okay. So here is where it gets done, right? So where it is, it's approximately at pi, right? It's approximately at pi it gets done. Did you see the number of petals? 7. And this was cos, right? So the highest value was 2. Did you see that? And it was on the horizontal axis. So now I'll give you one more. Let's see what to do there. Unless you're thorough with this, it's very difficult to move on. 9 sine theta, 8 sine 6 theta. 9 sine theta, 8 sine 6 theta. 9 sine theta, 9 sine theta, 8 sine 6 theta. Now, I would really like you to max distance from the pole, number of petals. What did I ask you then? Opens up or down or left or right. Then what else? Cycle. Can we try for each of those? What is the max distance from the pole for this one? 9 sine theta. How it opens? How the graph opens? It's a sine theta graph, right? It will open up or down or left or right. Or you can message me. Why don't you all message me? I'll know, right? Each of you. How do you understand?
Then up, right?
It opens up because sine is positive, right? It opens up and then
Since it's
maximum distance from
odd,
the pole is.
wouldn't it be maximum distance from the pole is 2 because the radius is 2, and then
No, wait. We are getting confused.
oh wait, sorry, I was looking at the wrong one. 9.
Yeah, I know. That's because even I got confused at first. Okay, let's do this.
Isn't the maximum distance 9?
Maximum distance is 9, and then number of petals.
Wouldn't it
Isn't it
have
just a circle?
1 petal because it's like a circle?
Yep. One petal means one round. That's it, one circle. Okay, and then cycle is what?
Cycle is 0 to pi.
0 to pi. Why? Because when we move from 0 to pi, you'll see that one circle is completed. If you move this line beyond this pi to 2 pi, it will just repeat. So that's why we call the circle as 0 to pi. Similarly, 8 sine 6 theta, what happens?
Wouldn't that also open up and the number of petals?
Will also open
Oh.
up. Cycle is definitely the same thing, 0 to pi. Number of petals?
12?
12. Maximum distance from the pole?
8.
8. So let's try 1. I'm not going to try 2 because of lack of time, okay? So let's see 8 sin 6 theta alone we'll see. Nitin, are you following?
Yeah.
Supraj, you?
Yeah.
What is that? 8 sin 6 theta. See? Are we clear?
Yeah.
See, we are not 8. But the cycle is what? Cycle is what? What will happen to the cycle? Cycle is, see, if it is even number, cycle is 2 pi.
Yeah. Oh,
Because when you come from this till here, right, it just completes only one set of petals. Another set of petals comes when you go from pi to 2 pi. Can I move on? Nidhi, are you with me, Nidhi?
you can move
Yeah.
Okay, good. Okay, now they can ask you endpoints of, meaning they can ask you, I want you to know these. Okay, you have to sketch a graph. Okay, find the endpoints of restricted domain and range. Okay, let's see this one. Okay, so we are going to be given a graph and I'm going to give you the endpoints. Let's see. This one we didn't do last week, I think, but I don't know. I don't remember at least. Let me make it bigger for my graph. I want to make it bigger. Wait. Let's do this one. We are going to do only 1 or 2 of this, please. How about this? Okay. 4 cos 3 theta. I want to find out the endpoints of C. When theta value is pi by 6 and when theta value equal to pi by 3, what is the value of R? First, sketch the graph. When we try to sketch the graph for this, right? 4 cos 3 theta. That means what? 4 cos 3 theta. It's going to be 3 petals, right?
Yeah.
Definitely the maximum is going to be 4. It's going to be 3 petals. So 1 petal. 3 petals means what happens? 2 pi, right? 2 pi has to be divided by 3. So the next one is going to be here.
And then wouldn't it be at 7 pi over 6 and 4 pi over 3, like in the middle of that?
Yeah. So third one is going to be what? Again, 2 pi by 3 plus, that will be 4 pi by, that will be 2 pi by 3, and I add, right? 2 pi by 3, 4 pi by 3. So that's going to be here. Make sense? But now if I want to find out, hey, what is the value at pi by 6? So what are we going to do? I'm going to substitute in there 4 cos 3 times pi by 6, right? And then for the other one, 4 cos 3 times pi by 3. So what happens? So you will have to give me the values at those two endpoints. Let's see what we get.
Wouldn't it be 1?
We'll see now. We're just going to substitute, that's all. 4 cos pi by 2 is what? 4 cos pi is what? You tell me.
Isn't 4 cos pi 1 and 4 cos pi by 2 is
4 cos pi is what, Ma? Here, right?
oh wait, sorry, -1, yeah.
Negative.
Oh yeah, I was thinking, yeah. And then wouldn't 4 cos pi by 2 be 0?
Yeah. So
Oh.
now what I can write about it? So pi by 6, the x coordinate, so meaning it's not a rectangular coordinate. So that is a theta value. The r value is 0. Similarly, the theta value was pi by 3. The r value was -4. Instead of saying x and y, I say it as r and theta. That's all. Supraj, are you following?
Yeah.
This is how I find the endpoints of given angles. Can I move on? Okay, now I would really like you to try at least one, not many. Let's see. 5 sin theta. 5 sine theta. Can you do 5 sine theta? And I want you to find out the endpoints of this. 5 sine theta. It's an easy one, right? Let me not take off the graph. It'll be useful, right? So let me do 5 sine theta. Okay. Now, oh, endpoints. Endpoints for what you need to find. Pi by 2 and pi. This is pi by 2. Can you do and send the answer to me? Pi by 2 to pi. Can we do that one problem? 5 is your maximum distance from the origin. So it has to open up 1, 2, 3, 4, 5. My graph is going to be like this, right? Now endpoints are 5 sine pi by 2, 5 sine pi. So what are the points here? Pi by 2, comma, what you need to find out?
Wouldn't
Here,
it be 0 and then 1 to 5?
so pi by 2 is a 5, right?
Yeah.
Sine pi is 0, right? Yep. So here it is a pi, here it's a 0. These are the endpoints. Got it? Okay, now let's move on. 8-3. Okay, Limicon, we just started with this Limicon. I really wanted to show you how this works. Okay. Basically, let's take this graph. 3 plus 3 cos theta. 3 plus 3 cos theta. How will the graph of 3 plus 3 cos theta look like? Do you all remember? How does the graph of 3 plus 3 cos theta look like? Okay, all the while we discussed what graphs, rose petals we discussed, right? Now I call this as limicon. Sorry for my pronunciation. I think it is called as limicon. Okay, how does your teacher say that? Naisha, you have covered it, right?
Yeah. I mean, we didn't really cover it. She, like, I don't think, like, she just gave us the notes and then it was done.
Okay.
She didn't explain anything.
Okay, I think it's pronounced as limicon. Okay. Okay, I'm not able to get to it because I am so used to pronouncing it as limicon. 3 plus 3 cos theta. See here, guys. This is of the format a plus b cos theta. Okay. Here we are going to have 3 variants. One is a equal to b, a is less than b, a is greater than b. The first thing we'll cover this. The second thing we'll cover this. The third thing we'll cover this. This is so important. Please listen. Okay. So now this is going to be 3. These are all, okay. The limicon can be called as 3 different things. When A equal to B, it represents a cardioid. You know why a cardioid? It looks like a heart, nice heart. Okay. Whereas A is greater than B, it's dimpled limicon. A is less than B, it is a inner loop limicon. Limicon. Okay. So these 3 will cover. Okay. Okay. Rather than breaking your head, you know how to draw this graph. Okay. The main thing I want you to understand is the concept. How will you match up the rectangular coordinate graph with the polar graph? If you understand that, I'll move on. Okay. When it is 3 plus 3 cos theta, remember guys, this is 3. Okay. Basically from 3, it's going to go up 3. So it'll go, oh, it's a cos graph, right? So it'll start at a 6, but then for pi by 2, then again, this is 3, right? Y equal to 3. Then what happens at pi? And then it goes up and above. This is 2 pi, right? So this is a pi. Any questions here? Any questions in this? Hey guys, you have to talk. Okay, so this is the rectangular coordinate, right? 3 plus 3 cos theta. Now the same 3 plus 3 cos theta, I am going to draw it in a, give me a minute. I'm going to draw it in a, I will paste this here so that it is there for our reference later. Okay, so now I'm going to go back to our polar graphing. Okay, GeoGebra link I'm going to share with you for you to play at home. I am just using a Desmos calculator, which is so bad. But with a GeoGebra, you can learn a lot, guys. I'm going to share with you to do it at home. Okay, the GeoGebra link is very good. I'll put it in the Google Classroom. It's very nice to play with. I was playing with it maybe last week and this week. So I'll share that link with you. But for now, let's move on, guys. I'll go ahead and graph this. Where is this graph? Polar graph is here. Okay, so this was what we did do. 3 plus 3, 3 plus 3 cos theta. Do you see, guys, how nice it is, the graph? See what happens here. It looks like a nice cardioid, right? CARD. The prefix stands for cardiac, cardiology, which is a heart. That's why I'm saying. So when they are equal, the limison becomes a cardioid. Any questions here? So how is that? How does that work? Similarly, 3 plus 3 cos theta. See, oh, I don't want it to show us. I want me to show. Okay, so here, do you see? So here it comes back. And then there you see the pi graph gets completed there. So what is the cycle for these graphs? What is the cycle for these graphs? You didn't get it, huh, Vibha?
Is it 2 pi?
Yes, 2 pi. Guys, meaning if you're not getting it, tell me, guys. See here, we are starting at 0. Okay. See the blue line, it goes to pi by 2. Okay, graph is not done. Then it comes to pi. Am I coming to pi? Why am I saying I'm coming to pi? See this blue color dotted line, it's coming to pi. Does it make sense? See, blue color dotted line is at pi. Is the graph completed? No, right? Again, it keeps going. Okay, it has various values. If you put a table, the values will come. Then again at 2 pi, it comes to the place where we started. So there is where the cycle gets done. So the the cycle for these graphs is 2 pi. 0, comma 2 pi. Am I making sense? Nitin, Supraj?
Yes.
Okay.
Yeah.
So this is a cardioid graph. The first one we did, right? The second one, I know I'm a little going fast, but yeah. Okay, so okay, I want to show you something else as well since we discussed this. What did we do? What graph was this we discussed? Okay, let's do. This is 3 plus 3 cos theta, right? R values. What do you think if you have 3 minus 3 cos theta? Where will the graph go? You tell me. Guess, guess. Guess based on what we studied earlier. What do you think? Guys, check.
Isn't it like,
Uh,
are you saying if it's negative?
Yeah,
Like,
meaning
wouldn't
if I have a
it just
negative,
flip? Like
yeah,
instead of the right side, it'll be left side.
correct. So what would happen? See, I'm not able to do that. I want to graph two things and show you. Let me quickly check. Wait, like a usual graph, can I do two? I don't know. 1 minute. I think I can do two. I want to do 3 minus 3. Yes. See, I'm able to do 2. Do you see it? Am I making sense? See, the green stood for the green color, the red one, I should have done it in black. So this is 3 plus 3 sine cos theta. It's on our horizontal axis. Do you see? And then the green color graph was 3 minus 3 cos theta. I just switched positions. Do you see? And how did I measure? See, it started at 0. This 3, right? This 3 here 3 plus 3, right? Or whatever here 3 and 3, right? That is your maximum 6. You get it? It starts at 0. The maximum value from the pole is 6. Similarly, what would happen? Can you all guess how a graph of 3 plus 3 sine theta and 3 minus 3 sine theta would look like? Any guesses?
It would just be up and down instead of left, right.
Yeah, it would just be up and down. I can draw and show you quickly. I don't feel like demoing. So that would be 6 means where? This circle, right? This one. This is, there's a heart. So this is 3 plus 3 sine theta. Again, this distance is 6. Now once more, 3 minus 3 sine theta is going to be down, but then let's move up. 3 minus 3 sine theta is going to be 3 minus 3 sine theta, right? Is going to be 6. 1, 2, where is 6? I really don't know. 6 is here. So it's going to come like this. So till, what did I do? Sorry guys, I missed the page. Hold on. Okay. So that's going to be 3 minus 3 sine theta. So this is the pole I'm going to start, but this is, it's going to be like this. Am I making sense? Okay, so we finished cardioids. In the sense, you know what is cardioids, how to predict the graphs. Okay, now I really want to go ahead with A is, I told you right? I want to go ahead with the dimpled limicon. Dimpled limicon means A is greater than B. I want to go ahead with this. Oh, I can't paste. 5 plus 3 cos theta. Let me show you. 5, I'm going to erase this graph, okay? 5 plus 3 cos theta. Do you see it? Now we are talking about the second category of limicons. Second category of limicons where you have A, B. Values are in here. But how do you think this graph is going to be? This is going to be a dimpled limicon, right? So first let's see how the graph is going to be. Okay. Now I just want to erase these graphs. This is so confusing. Okay, this is 5 plus 3 cos theta. So A is greater than B. Do you see? So as I said, the 5 and 3 added value becomes your radius. This, do you see? 5 and 3. 5 and 3. 8, right? Wait. This should be, we have time, right? Okay. Do you see? So here, do you see? Here it is. It starts with 0. Do you see 5 plus 3, 8? This here it's a little different. 5 plus 3, 8. And you know what? This side, left side, guys, we need to be a little bit here, clear. This is your distance from pole to the right side. Whereas, what is this left side? You subtract 5 and 3, this becomes your left side. This is A minus B, this is A plus B. This is in case of a dimpled limicon. This is the second category of limicons, which is a dimpled limicon. Cardioid, the thing was, this came here, right? So you only had this part where A plus B was there. Whereas in a dimpled limicon, dimple means this appears as a dimple, right? This dimple does not come to the pole. This dimple happens at A minus B value. Any questions? So this side is A minus B, this side is A plus B. Do you have any questions on that? Naisha, you're good?
Yeah, Auntie, I'm good.
Okay, now 5 minus 3 cos theta, how is it going to be? What do you think?
Just the left side.
That's what I'm thinking too. Yeah, it's going to be that. I want to erase all my drawings. Yeah, that's going to be that. Thing here is 5 minus 3 cos theta. Again, think about this. 0 to this. This is A plus B value. Whereas this, the pole to the dimple point, right? That is A minus B on the other side. Any questions? So what would happen if I have r theta equal to 5 plus 3 sine theta? r theta will be equal to 5 minus 3 sine theta. What would happen? What would happen, please? Try.
Just up and down.
Yeah, that's all. 5. But the thing is, you need to be careful about the 8 and 2. So if I change it to 5, let me change it and show you. Nitin, are you with me?
Yeah.
Okay, so 5 minus 3. If you're not understanding, stop. 5 minus 3. Do you see it? So in this scenario, I want to erase this off. This is very confusing. See what happens. A plus B, A minus B value is very important. A, B, right? See here, from here, this should be 8. Let's see. Yeah, that's 8. Do you see? 8 is here. Okay, and from the pole to the dimple will be 5 minus 3. But we are always using 5 plus 3, 5 minus 3, 5 plus 3, 5 minus 3. I don't want you to sit with that value always. How about 5 minus 2? See what happens. If I do 5 minus 2, 7 and 3 comes into play on the top. 7, 7, this is A plus B, and 3. Do you see on the opposite side? Did you guys get it? Biba, are you following?
Yeah, I was just trying to look at it. Cause like it's like zoomed weird on my screen.
You want me to make it bigger, I'll make it bigger. But please try to understand here, guys. Take advantage of the class. Otherwise, it's very hard to follow or write the
I
exam.
think I get it. Oh, that's like the same thing. So like the same thing with cosine and sine. It's just like one's taught. Oh, cause sine is always vertical, right?
Vertical. Cos is always horizontal.
I
Okay. Now, the last graph, what did I tell you? A is less than B. The value switch to plus 5 sine theta. See, there is an inner loop limicon. 2 plus 5 sine theta, 2 minus 5 sine theta. See, guys, this is called the inner loop limicon. So let's not do 2 together. Let's first understand what is going on. 2 plus 5 sine theta. I want to expand it. So now what is this? This is the third category where my A is less. Where my A is less and sine is vertical, right? But A is less. Do you see? So when you look at this, right? Let me, I don't want this big of an expansion. Let me do it a little bit low. So when you look at this, what is this value? What is this value? This value is 7. Do you see? This value is 7. Okay, this value is 7. That is always A plus B, right? To the pole is always, this is 7. This is that's a 5 plus 2. Whereas for the inner loop, right? Did you see the inner loop maximum is here? What is that value? Inner loop is 3. Where did that come from? 5 minus 2. That is, this is A minus B. This is A plus B. Am I making sense? Cardioid is A equal to B. A greater than B is a dimple. Dimpled limison. Okay, and then A less than B is a inner loop limison. Inner loop limison. Dimple limison is also one loop limison. I don't know. I have to check. Inner loop limison. Okay, these are the general names that we call with. Okay, so this is of the format A plus B cos or sin theta. For this one, it can be a cardioid, it can be a dimple limison, or it can be a inner loop limison. Nidhi, are you with me?
Yeah.
Okay. If you're not understanding, you have to stop right away. Okay. One thing what I want to show you is the comparison, right? Between the two. Let's see. I want to compare and show you anyway. See, that's where I want you to go for the GeoGebra. You want me to show the GeoGebra location, right? That you need to know, because then only you can compare both. For that one, let me see, guys. Give me a minute. I want to go to the GeoGebra location. Did I note down the GeoGebra? I don't know. Wait, let me see. No, it is somewhere else. Hold on. Okay. Yeah, I think I have the GeoGebra thing. GeoGebra. Ah, see, I noted down. Okay, here we go. Let's go back. In the same. Are you all seeing the graph, guys? Okay. See, I see, please, this is where you will understand what is going on. So, how this is converting to that 1 plus, okay, we were discussing the same thing, right? So, why don't we go ahead with this? 1 plus 2 cos theta. This is A less than B. So, what type of a graph will be? It will be an inner loop limison. But the thing is, sometimes they'll ask you, when you go from here to here, right? The graph is decreasing. The graph is decreasing, right? And then it's positive. How about this part of the graph? The graph is decreasing negative. How about this part of the graph? Increasing negative. How about this part of the graph? Increasing positive. Do you guys get it? Do you guys understand what I am writing on the rectangular graph? You get it, right? See, from 0 to this value, whatever it be, to this x value, it is positive and decreasing. It is moving towards the pole. It's moving towards the pole. Decreasing and negative, it's moving away from the pole. Right? Pole is your horizontal pole. See, this is your pole. Okay. This is the horizontal axis, right? So now increasing negative. So what is happening? It's going towards. Yeah. And then increasing positive, it's going away. Any questions here? Any questions? So in a rectangular graph, you should be able to say when it is increasing, decreasing, when it is away, when it is positive, when it is negative. All that you need to be able to say when we go to the rate. Okay. So for now, we have just finished the limicons. I will share this GeoGebra link with you. You can do it at home. Okay. Now, I wanted to compare two graphs. Let me compare two graphs. We were comparing the rectangular and polar, right? I'll go ahead and show you the relation. Now, let me share my notes page. Let me erase off all this. I'll show you the comparison. See here. There is a 3 plus 3. Let's see. There is a 3 plus 3 cos theta, right? So what cardioid, right? Naturally, they both are equal. So it's a cardioid graph. But I want you to compare this. So cos graph, right? Cos graph, what happens? It
Yeah,
starts with a, yeah, ma?
Auntie, I
I can
can't
see
see your
black.
screen.
You can see my screen?
Mm-hmm.
Yeah.
I'm glad you told me. Is it clear?
Yeah, I can see it now.
Yeah.
Good, good. Okay. So now I just want you to be able to compare these two. See, cos graph starts with the highest point in a rectangular point, right? So what happens? It starts, these are the 3 points which can be compared, right? 1, 2, 3, 4 points. 1, 2, 3. Pi means it goes to 0. Pi is, hold on. Pi becomes negative. It's 3 plus 3 cos theta, 0. This is 0, ma. This is 3. This is 6. Okay. So now pi is 0. So this point corresponds to pi is 0 point. Okay. So this point corresponds to this point. Please, if you don't understand, ask. Okay. And then 0 point goes to 6. So that corresponds to 6, correct. Then the next one, let me see. What is this? Pi by 2, right? Pi by 2 corresponds, pi by 2 is here. Pi by 2 corresponds to a 3. 1, 2, 3. Am I making sense, guys? Am I making sense? So,
Yes.
Nidhi, are you clear?
Yeah.
Okay. Now, one another point what we can say, what we can ask for. Can I ask for this one? What is this? 2 pi. I don't want 2 pi. 2 pi is a repeat. Let's do 3 pi by 2. 3 pi by 2. Let's not do this. 3 pi by 2. Where is that 3 pi by 2? 3 pi by 2 is here, right? So that is going to be what? 3. Do you see, guys? Am I making sense? So you can clearly relate these two. Okay. Now, if I'm going to ask for, one second, let's see. If I'm going to ask for this period, 0 to pi by 2, what is happening to the graph? In this period, 0 to pi by 2, see what is happening. If I say in this period, 0 to pi by 2, this is clearly, I don't want this. Clearly, it's decreasing. Clearly, it is decreasing, moving towards the pole, and R is positive. So what is that? What is that period? 0 to pi by 2, right? So that is this part of the graph. Am I making sense? This piece is that part of the graph. Any questions, guys? Then the next part of the graph, this is how you have to split, and then only you'll understand things. Otherwise, nothing will be clear. Pi by 2 to pi. Pi by 2 to pi, what happens? This is this part of the graph. So here what happens? It's still decreasing. R is negative, and then it's going away from the pole. This pi by 2 to pi. See, this is your pole. This is your pole. Hey, wait. This is as well. Yeah, correct. Decreasing. And then this is as well towards the pole. I'm sorry. See, that's why it's coming towards the pole. This is coming towards the pole only. Okay. See, this is as well. The black color thing is also coming towards the pole. Am I making sense? It's very clear when you
Auntie, I
start.
have a question.
Go ahead.
On the rectangular graph, is there like a position where we like consider the pole?
Yeah, ma, the XY axis, the x-axis.
Oh, wait, that's translated up. I didn't see that.
This is that it's not marked. So I just said it as a this is the horizontal axis.
Oh,
Because
okay.
you get it?
Yeah, I thought it was a line in the middle. I thought, oh,
Line in the middle is your midline.
midline. Oh, I
Ah.
thought that was the x-axis. Okay.
No. See, that's a little confusing. Okay, that is why, see, this is all decreasing. It's all moving towards the pole. You get it? But it is all R is positive everywhere. Here it's positive, R is positive. You got it?
Yeah, thank you, Auntie.
Now, the next part of it, let's see. R is moving away from the pole. See, it's moving away from the pole in this. And then for the last piece, right? This one. You got it? Are we clear? It's still moving away from the pole, but increasing. So like that, if you can compare, the rates will be very easy. I'll cover rates and move on to the fourth unit next week. Okay, any questions? Are we able to compare and graph now? All the limicons, rose petals, and I can show you one more, please. Okay, I'll show you the Archimedes spiral and then let you go, please, because I don't want to keep that for next week. Give a minute, guys. I just want to clear this. Let's see, Archimedes spiral. This is good. Yeah, Archimedes spiral, I really want to. Okay, how about this, guys? Can you predict what this graph is? I would really love for you to tell me what is this graph. What is the equation of this graph? What is the equation of this graph? You want me to make it bigger?
Yeah,
I'll,
just make it a bit
Yes,
big.
please.
yeah, I'll make it bigger. Wait, let's sit and find out. Okay, see, at the end of it, that's what we want to know out of the class, out of this class, right? So let's see. It's okay if you don't know as well. Try. So what is this graph? Is it a one loop lemicon or a cardioid or a dimple
It's a
lemicon?
dimpled,
Dimpled.
right?
Dimpled means what is the scenario? It is definitely
A
going.
is greater than B.
Exactly. So A plus B, it's a vertical graph.
So
A plus B
sine.
sine theta. Right? A plus or minus B sine theta. Let's do it that way. A plus or minus B sine theta. It's a dimple lemicon. So let's see.
Wait,
Hmm.
A would be 4, right? Because
A would
it
be,
touches.
this is 6, ma? 4 or 6?
Because
Yeah, yeah,
isn't
yeah.
it like
Correct, correct. A is what? Correct.
4?
A is 4 and here there is a 2. So what happens? Correct. So 4 and 2 makes up 6. 4 minus 2 makes up 2. So A is 4. Okay. And B is 4 or A is 4, ma?
Isn't it A is 4 because A has to be greater than B for it to be dimpled?
Oh, yeah, yeah.
So
A,
4 plus B
correct,
sine theta.
correct, 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 correct. 4 plus, very nice. 4 plus
2 sine
2
theta.
sine theta. 4 plus 2 sine theta. Yep, that's correct. So tell me, in this domain, let me ask you this.
Wait,
In
Auntie,
this,
can I go? I have to go.
yeah, you can go, ma.
I'm really sorry. I have
No,
to this.
no problem, ma. No problem, Vibha. Keep going.
Auntie, thank you.
Pi. Pi by 2 to pi, is it positive or negative? Pi by 2 to pi is a yellow color highlighted line. Pi by 2 to pi, is it positive or negative? See, here is where we better do it in a rectangular form, a rectangular graph. That is where you can easily find out if it is positive or negative. Let me show you the corresponding rectangular format. Rectangular format, you'll have to sit and draw, but I have it in here. We can look at it. Then you can tell me. Between pi by 2 to pi is a yellow color highlighted line again. So is it positive or negative? You tell me.
It's positive.
Yep, it's positive. Is it increasing or decreasing?
It's decreasing.
Yep, that's right. So if you have a graph like this, I would better prefer for answering these questions like whether it is increasing, decreasing. Okay, for the time being, till you get used to the polar graph, it's so much better to work it out into a rectangular graph. Should be easy, right? Because this is amplitude is 2. Okay, so this distance is 2, but it is raised by 4, right? So this is y equal to 4 line. This is y equal to 0 line, right? So in a rectangular coordinate, it's easy to understand. So when you put this graph quickly, then you'll clearly understand, hey, in this interval, is it increasing, decreasing, positive, negative? You can answer it very well. Okay, that's the takeaway from this class. Anything, any property for a polar graph, if it is rose petal, limestone, you should be able to do. Archimedes spiral, I didn't cover. So rates and Archimedes spiral, we'll do it next week. Okay. Thank you guys. See you all
Thank
next
you,
week.
Auntie. Have a great week.
Bye-bye. How are you guys? 1 second.
Good.
Let me stop share and then reshare, guys.